The launch of JS Sōgei marks more than the introduction of another Taigei-class submarine. It represents a strategic and technological milestone for Japan's underwater fleet. For decades, the strength of the Japan Maritime Self-Defense Forces submarine service has rested not on nuclear propulsion or raw endurance, but on silence, sophistication, and intimate familiarity with the operating terrain of the Western Pacific. JS Sōgei continues that lineage, while also raising a new question among defense analysts in Tokyo: whether Japan should at some point transition toward nuclear-powered submarines, or whether it should continue perfecting its diesel-electric lithium-ion approach that has yielded exceptional results so far. The Taigei-class, of which Sōgei is the sixth vessel, builds on the strong foundation of the earlier Soryu-class. However, the shift is not superficial. The most defining characteristic is the abandonment of the Swedish-derived air-independent propulsion Stirling system in favor of a far more capable lithium-ion battery architecture. This enables higher sustained underwater speed, faster torque response, and operational profiles that blur distinctions between conventional and nuclear-powered behaviors. Unlike a conventional diesel-electric submarine with traditional batteries, a Taigei-class boat such as JS Sōgei can sprint underwater, maneuver aggressively, and then slip into near silence without surfacing. The tactical implications are significant for tracking, tailing, and evading in contested waters. Japan's choice of lithium-ion technology instead of AIP suggests a philosophy of underwater warfare built around flexibility rather than long-endurance station-keeping. Japan's submarines are optimized not for remaining submerged for months in open-ocean patrols, but for dynamic engagement in choke points, straits, and regional seas where energy agility matters more than sheer endurance. Surrounding Japan are multiple maritime corridors: the Ryukyu Island chain, Tsushima Strait, Bashi Channel, and the deep trenches east of Honshu. In such environments, the ability to accelerate quickly, reposition silently, and integrate with regional maritime sensors may outweigh the ability to remain submerged indefinitely. Yet the discussion of nuclear propulsion is resurfacing in strategic circles. The emergence of Australia's planned nuclear submarine capability under the AUKUS framework echoes across Tokyo's defense community. Japan remains constitutionally restricted in some dimensions, but strategic doctrine evolves. If the operating concept were to expand from regional defense to broad-range Pacific shadowing, if future threats demanded persistent tracking of adversary carrier groups in distant waters, then the argument for nuclear propulsion would gain new traction. Nuclear power offers virtually unlimited underwater endurance and independent global mobility, but it also comes with organizational, legal, safety, and industrial implications that would require enormous national investment. The Japanese technical workforce is an overlooked variable in this conversation. Constructing and maintaining nuclear reactors for maritime use requires a multi-generational skill pipeline. Nuclear engineers, reactor safety specialists, radiation protocol operators, and secure shore support infrastructure. Japan certainly possesses robust civilian nuclear knowledge. However, converting that expertise into military-grade submarine reactor programs is non-trivial and would almost certainly require structural political consensus. The Japanese political approach to military innovation tends to prioritize incremental capability accumulation rather than theorem-based leaps. For now, Japan's comparative advantage remains acoustic stealth. JS Sōgei's internal structure features vibration isolation measures, hull coatings designed to absorb rather than reflect sonar, and refinement of propeller geometry to minimize cavitation. These features matter in the Western Pacific, where submarine encounters are often determined not by sonar power alone, but by the ability to remain undetected among complex acoustic environments shaped by sea temperature layers, undersea ridges, and ambient shipping noise. From an operational perspective, the Taigei-class fleet enables Japan to maintain continuous surveillance presence in critical maritime zones without advertising its presence. In a peacetime tension environment, that presence is not destabilizing because it is invisible. In a wartime contingency scenario, this invisibility becomes an asymmetric advantage. A nuclear submarine may dominate in sustained blue water pursuit, but a lithium-ion enhanced diesel-electric submarine may dominate in silence. There is also the matter of cost efficiency over time. A nuclear submarine is not merely a vessel, it is an ecosystem. The life cycle cost encompasses reactor maintenance, high-integrity containment protocols, specialized dry docking, and strict regulatory oversight. Even beyond the technical challenges, the symbolic nature of a nuclear-powered Japanese warship may trigger regional reactions. Japan has chosen a defense posture emphasizing responsibility and technical reliability. A shift toward nuclear propulsion would be interpreted differently by neighbors and even by domestic constituencies. Japan therefore faces a choice not between weak and strong, but between two philosophies of strength. One is nuclear endurance, the ability to remain submerged for months, to roam across oceans, and to appear anywhere unexpectedly. The other is lithium-ion stealth, the ability to own the acoustic battle space in Japan's maritime neighborhood, to disappear into trenches and channels, and to reappear where adversaries least expect. Japan is leaning toward the latter because it aligns with mission reality, defending the Japanese archipelago and its surrounding waters rather than pursuing global underwater dominance. JS Sōgei embodies this approach. It is not impressive by tonnage metrics or reactor output, but by the combination of discretion, speed, and silence. It reflects a uniquely Japanese military engineering ethos, one that values precision over intimidation, discipline over theatrical display, and enduring competence over rapid escalation. The submarine fleet Japan is building is not designed to broadcast strength, but to ensure that no hostile movement below the waves goes unobserved or unchallenged. In quiet, JS Sōgei represents a different form of deterrence, not the deterrence of threatening posture, but the deterrence of uncertainty. No adversary can be sure where it is or whether it is already nearby. That uncertainty is a force multiplier. Whether Japan eventually develops nuclear submarines will depend on the evolution of its strategic horizon. But regardless of propulsion type, the real strength lies in Japan's mastery of underwater warfare knowledge, acoustic intelligence, shipyard precision, and disciplined seamanship. That is the foundation upon which any future fleet will be built.